All right, in this lecture I want to show you something kind of neat about tuples, and to use that to introduce this really important concept in programming languages called syntactic sugar. So let me just show this to you in the REPL. We have already seen how to build pairs. Here's a pair, 3 plus 1, 4 plus 2, creates the pair 4, 6, no problem. And similarly, we could create a record maybe with a field second of 4 plus 2 and a field first of 3 plus 1. All right? So nothing unusual there. We see that tuples and records are similar but different. But now suppose I did something kind of strange. And I made a record, but I made the field names say 1 and 2 in whatever order I want, because the order never matters. Something like this. Watch this. Oh, isn't that weird? I made a record with field names 1 and 2, and the REPL printed it out as a pair, 6, 5, and it printed the type as int star int. It's like it turned my record into a tuple or something. Of course, this is no problem, right? If I wanted to, say, take hash 1 of a pair and add to that hash 2 of another pair, underscore, not plus, there we go. I get 9 of type int, and for hash 1 and hash 2, it doesn't really matter. Hash 2 can mean get the second component of a pair, or it can say get field 2 of a record, right? So it doesn't seem to matter. And just to show that you really can give numeric field names to records, if I had a record like this with 3 and 1, all right, well, that prints as a normal record. It has type 1 colon bool, 3 colon string. But if I had something with 3 equals high, 1 equals true, 2 equals, say, 3 plus 2, now I have a triple, true, 5, high, bool, star, int, star, string. And what I want to convince you is that this is because there's no such thing as tuples in ML. There are only records. And tuples are just a different way of writing records that you as the programmer can use whenever you want, and the REPL always chooses to use if it can. And this is because tuples are just quote-unquote syntactic sugar for records. So let's unpack that idea a little bit here. Okay? Previously, I taught you tuples as though they're in ML. We gave syntax, we gave type checking rules, and we gave evaluation rules. But we could have done something else instead. I could have taught you records first, even though they're a little more complicated, and then told you that there's some special syntax for writing certain kinds of records. That whenever you write the syntax for building a tuple, E1, comma, up to En, in parentheses, that's just another way of writing the record with field names 1 up to N and with the corresponding expressions. And whenever you write the type for a tuple type with those stars in between the component pieces, that's just another way of writing the record type where, again, the field names are 1 through N. In other words, tuples are nothing more and nothing less than records with particular field names. And that is how the ML language definition actually works. That all there is about tuples are special syntax that you can use when writing programs and that we print when we write the results of things in the REPL. So you really can write things like the record 1 equals 4, 2 equals 7, 3 equals 9. It's terrible style. I don't know why you would do this. The tuple syntax is easier to read. It's what people expect. I just showed you this for the purpose of teaching you this idea. But it really is that in ML we have records. Tuples are just a particular way of writing particular records. So what we say in programming language speak is that tuples are just syntactic sugar for records with fields named 1, 2, up to N. So I'm going to use this phrase a lot in the course, so let's understand exactly what it means. Syntactic, because we can describe the semantics, the evaluation rules and typing rules for tuples, completely in terms of something else, right? We do this just, you wrote this, it's like you wrote that, and then we can use all the semantic rules we have for a different language construct. So that's why it's called syntactic when we do this. We call it sugar because it makes the language sweeter. It's a pleasant thing to use in C, so we call it syntactic sugar. We're going to see many more examples of this. Syntactic sugar is great because it simplifies our understanding of the language. once you understand how tuples are really a form of records, you understand everything there is to know about tuples as long as you understand records. They also simplify implementing the language. The ML implementation just has to convert tuples into the corresponding records, and there isn't as much duplicative work to do. We only have to implement one kind of each of type instead of two. Okay? So this is far from the only example we'll see. There are other examples of syntactic sugar, and actually we've already seen one other. You can think of E1 and also E2 as being syntactic sugar for if E1, then E2, else false. Right? We can explain everything there is to explain about and also in terms of that syntactic transformation in terms of an if then else, and also is better style, but we can define its semantics in terms of another concept we already understand. So that's syntactic sugar, and now we understand the truth about tuples.